Hi everybody. Last week you looked at a scenario where a cart was being pulled by a bob. That bob was hanging down to the ground, and you sort of connected the mass of the cart to how much that cart was going to be accelerating. You also connected the mass of the bob to how much that cart was going to be accelerating. In that situation, if you change the mass of the cart, here's an example data table that somebody in your class collected. You can see that as the mass goes up on the cart, the acceleration goes down. Somebody else added mass to the hanging bob and found the acceleration, and they found that as the mass of the hanging bob goes up, the acceleration also goes up. These are two different relationships. Both the added mass to the hanging bob and the mass on the cart affect the acceleration. What I want to do now is take a moment to sort of talk about what an equation for that acceleration is going to be. And I'm going to propose something here. First thing that I'm going to propose is this looks like it has a negative slope. It does. If we were to zoom out, we would kind of see that it sort of makes this curve here. And it doesn't cross either of the axes. It just sort of makes that curve. If you think about an operation where if the mass gets bigger and bigger and bigger, your acceleration is going to get smaller and smaller. An operation that might come to mind is division. So what I'm going to do here is I'm going to suggest in this equation that the mass of the cart, the mass of the system, the mass of the thing that's moving goes in the bottom of your equation for acceleration. If you have some number and you divide by a really big number, 10 divided by 1,000, your answer will be very small. This equation tells us as the mass gets bigger and bigger and bigger, you're dividing by a bigger and bigger and bigger number, your result is going to get smaller and smaller. That's the same thing that this graph says. As the mass gets bigger and bigger and bigger, the acceleration gets smaller and smaller and smaller. So we're part of the way there with the equation right here. And this part came from the first graph. Somebody else said as the mass to the hanging bob increased, the acceleration increased. And why is that? I think if the hanging bob increased, then there was a bigger force of gravity on it. There's a bigger pull. So by adding mass to the hanging bob, we're increasing the force. I'm going to put the force in the top of the equation, just like so. Here's what I'm going to propose as an equation for us to use. Acceleration is affected by two things. Acceleration is affected by the force applied on an object. Acceleration is affected by the mass of that object. Acceleration is affected by those two things in this way. This is the relationship where acceleration is equal to force divided by mass. What I want you to do after you watch this video is go to this link, and you can just play around with the setup. I'm going to restart. You can click to show the values and to show the masses. Here we have a 50 kilogram cart. I'm going to start putting 1 Newton of force on it. Oh, that's not very much. Let's say I'm going to put 25 newtons of force on here. And then I want to see what's happening to the speed.